So you make t, you saw the formula, make t the subject in equation 8, right? So, and that will be, my equation 8 is SAX equals to V naught cos alpha t. So if I make this t subject, my t will give me SAX all over V naught cos alpha. So I'll call that equation 9. Are we good? So also you put, or you substitute t in equation 9. Equation 9, this is 10 here. So t in equation 9. So where's my equation 9? My equation 9 is SAY equals to V naught sine alpha t minus GT squared over 2. Are we good? So let's start substituting in. So my SAY will give me V naught sine alpha. Instead of writing t, I'm going to put this guy. That'll give me SAS all over V naught cos alpha. So minus GT, G, so I'm putting my t. I'm going to put SAS all over V naught cos alpha, but it has a square. The t has a square, I put square here. So all over what? This my g is over 2 here. All over 2. Are we good? So my XAY will now give me, if I open the bracket, I bracket SAS, because this V naught, we equate this V naught. So we have sine alpha over what? Cos alpha minus G SAS square all over 2 V naught square, curve the square, cos square alpha. That again. Now recall tan alpha is equals to sine alpha over cos alpha. So I will now see that my SAY will be giving me SAS tan alpha minus G SAS square all over what? 2 V naught square cos square alpha. So this is my equation of a parabola. Are we good? So now let's see how it goes. From here, recall that in 2 occasions, this is the equation of a parabola. So notice that in 2 occasions, our SAY is equal to 0, right? One of those situations is at the beginning of motion, SAY is 0, and at the end of the motion, SAY is 0. So at t equals to TA, SAY is equal to 0. At t equals to what? TB, SAY is equal to what? 0. So now from equation, let me call it to be my equation 11, right? So from equation 9, we have SAY equals to V naught sine alpha t minus what? GT square over 2. That is for my equation 9, right? Now, we know SAY is 0 because it's displacement. If I have my projectile this way, the ball, this SAY, if the ball should go up, it will come down back to that same point. So the displacement there is 0. So our SAY here is what? 0. So we have 0 equals to V sine alpha t minus gt square over 2. Are we good? So from here, what we'll do here is this. So if I take this guy, we're having v naught sine alpha t. Let me put this a negative here, is equals to negative gt square over 2. Negative of negative, right? So my t, one t here will cancel one t here, so we left with v naught sine alpha is equals to what? Gt over 2. And if I can multiply, I'll be having 2v naught sine alpha, right, equals to what? Gt. So if I divide both sides by gt, I'll be having 2v naught sine alpha all over what? G. Are we good? Equals to what? T. So this is my time of flight. Either I put it this way, or you say T, is equals to V naught 2 sine alpha over G. Any of them, but this is my time of flight. So in this case, read it as what? Capital letter T, if you want to. Either it says capital letter T, that is the time of flight. Right? Any of them. So thank you. That is one. So proceed. Substitute T in equation 8 to get horizontal distance, which is what? SAS, right? So we know that my SAS or my range is equals to V naught cos alpha t. So if I want to write that, my range will give me V naught cos alpha. Instead of me putting my t, I'm going to put the t I got here, which is 2V naught sine alpha all over G. Are we good? 2V naught sine alpha over G. So my range will now give me V naught times V naught will give me V naught square. Cos times alpha, we're having 2 sine alpha cos alpha, everything all over what? Over G. But recall 2 sine alpha cos alpha is equals to what? Sine 2 alpha. That is trig relationship here. So we'll now say therefore my range will give me V naught square sine 2 alpha all over G. So this is my horizontal range. Thank you.